just say a couple of things. So the next test, you should expect your next test should be somewhere around the 27th of April. That's 2 weeks away. The 20th, that's a Friday. So 1 week from this Friday. When I say last test, I mean your test 4. So we will finish chapter 5 this week. For sure, we may even get to 6. 6 is only a couple of slides. So we may finish all of 5 and 6 this week, or we'll finish 6 on Monday. But either way, we'll have time to do, my plan is to have time to do a study guide on Wednesday of next week. So that makes your test will be on Friday of next week, your test 4. So that's the 27th. I will probably send out a study guide this weekend, this coming weekend. So you'll have it over the weekend to practice on, take a look at, try to do it before I do it. So test 4, April 27th. That means that on that Monday when you come back, of course, I'll give you your test back, but that's the day that we'll have to practice for anything for the final exam. And usually for the final exam, I use your test, all of the previous tests that you had. The good thing is that chapter 3 and test 3 and 4 will be more fresh on your mind. Chapter 1 and 2 are the parts that we want to definitely bring back to your memory. So that's the plan for that Monday, is to do a refresher of what we forgot from chapter 1, not chapter 1, but test 1 and test 2. So bring test 1 and test 2 back with you on that Monday, which is April the 30th, which is our last official lecture day. Okay? All right. So with that said, the only thing I wanted to mention about the slide that you see on the screen now is just that we talked about logarithms in the previous previous class. And from the previous class, here's where we did last time. So you can see all the properties. I gave you examples of all of the properties of logarithms from last time. And then, of course, we always go to find out how can this be used in real life. You won't have to use it unless you want to be a, what is that called when you're an earthquake person? It has a name. I'm trying to think. It's a, it'll come to me in a second. But either way, if you're going to do some work in that field, then you would use this information, and it would already be built into whatever software you're using to determine the intensity of the earthquake. But it's like a seismologist or something. Okay, that's it. All righty. So if you're going to be a seismologist, you would use this information. I don't know if you guys are going to go chasing earthquakes. I'm not. So again, this is where this information would be used in real life. So 5.3 is what we're going to do today. We'll get through as much of it as we can. I'm not going to try to rush, but we'll get through it because we have plenty of time to finish this and finish the chapter. As you can see, we've only got like 12 slides left to finish this entire chapter. So, solving equations. When it says solve an equation, what are you going to do when it says solve an equation, or what do you think you're going to try to find? Anytime you see the word solve, you're solving for x. You're just trying to figure out how to get x by itself. That's your goal when it says solve. So even whether you're solving exponential or logarithmic equations, which we're going to do in this section, you're just trying to get x by itself. You're trying to eliminate everything else and get x by itself. So let's look at the first example of how to solve an equation and get x by itself. We're going to walk through it, even though you already see it's been walked through on the screen. There may be a step or two that's missing that I'm going to add to it. So you have an equation that says 3,000 is equal to 150 times 10 to the 4t power. I have a question. Is that an exponential function?
Yes.
Yes. How do you know?
The
The t is the exponent. Is it increasing or decreasing?
Increasing.
Increasing. What's A? 150. What's B? What's K?
4.
Done. See, so you see how you got that? So you know that's an increasing exponential function. They set it equal to 3,000. We got to figure out what the t is. They've already said 150 times 10 to the 4t power equals 3,000. Well, what's the t that makes that equal to 3,000? That's what they're asking you. Tell me what t value works for this equation to make it equal 3,000. So when you have an exponential equation, somewhere we're gonna have to use logs to figure out the answer. All right, step one. We have to divide both sides by 150. So that's gonna be your step one, to divide by 150 on both sides. Why am I doing that? Because I need t to the 4t power by itself. That's my first goal. Get t to the 4t power by itself, because the goal is to get t by itself, right? So I'm doing little pieces at a time. So I'm gonna get t to the 4t power by itself. So here is, what happens to my 150 over 150? Cancels out. So I'm left with 10 to the 150 on the right side of the equation. What's on the left side if I simplify? How many times does 150 go into 3,000? Is it 20? Is it 200? Is it 20? Well, I know 2 times 20 is 150. It's 300, so 20. All righty. Do I have t by itself yet? Is it in a simple exponential form? Yes. When it is like that, you can do the circle method. Now I'm going to read, so here's step 2. Step 2, do circle method. Alrighty, so I'm just going to rewrite the equation so I can do the circle method so you can see it. Alrighty, so circle, where do I start? Okay. Is that last arrow, is it pointing to the 4 or to the 4t? 4t. Okay, alrighty. So, I am now for step 3, rewrite in log form from the circle. You're rewriting it in log form from the circle that you just did. So log, box here, a box here, and a box here. Okay? What goes in the first box? 10. Okay. Second box?
20.
Third box?
4t.
4t. You okay so far? Now I'm going to write it without the boxes. I'm just rewriting without the boxes. Now, when I rewrite it, do I need to put the 10?
No.
No. But if there was any other number, you have to put it, right? Yes. Anytime there's a 10 here, you never have to put the 10 because your calculator already knows that's a 10. If you have ever a 10 in there, you don't have to put the 10. What am I trying to get by itself?
T.
What should I do to both sides to get t by itself? Divide by what? Divide that side by 4. Divide that side by 4. There we go. So now, what we going to put in the calculator? This has got to go in the calculator. Put this in your calculator. Somebody go. Now you got to make sure you put this in your calculator properly. What I would do, depending on how your calculator functions, I will put log of 20. Sometimes you might have to put parentheses around it. Depends on how your calculator functions. If you do it a certain way, if you put log and then 20 divided by 4, it thinks you did this. Here's what the calculator thinks you did if you do it a certain time. So it depends on how you type it. If you don't have any parentheses here, it might think you want to do this. This is not what we want. We want this. So that's why I say if it allows you, or you can just say log 20, hit the equal button. Put log 20, hit your equal sign, then divide by 4. So we should all get the same answer. Now, you see the answer on the screen. What's the approximate answer? And did you get that answer?
Yes.
That means you put it in the calculator properly. Everybody should get that same answer. We all should get the same answer. In the homework, it'll tell you how much it wants you to round to. 3, 2, 5, 2, 6. All right, questions?
I remember you said the 10 was the default, so we just don't put it, we don't do
Correct.
anything else with it,
No, you type log 20.
and that's it.
That's it. Now, had it had another number, we'd have to do something, we'd have another button that you need on your calculator. So, while we're saying that, that's gonna take us to the next slide to answer your question. If it's log base 10, you can just hit that button in your calculator. What if it's not base 10? What if it's log base 4, or base 6, or base 15, or base 25? What are you gonna do if if you need to put in log base 4? That's what the next slide is gonna talk about. So let me make sure you're okay with this one. Were you okay with this one? So in the slide that you see on the PowerPoint, it skipped a couple of steps. I just always add in a little bit more detail just to make sure when you go back and look at your notes, you can see exactly what step might have been missing from the original PowerPoint. You okay? I'm just trying to make sure you followed it. You followed me? Mm-hmm. Okay, all right. Next slide. And let's see, we'll get to the information on the 24th slide. I'll show you what I really want to show you about this one. All righty, so now we are again solving an exponential function. I'm going to write it on this side of the board. Let's see, I didn't skip a slide, did I? No, but I should have switched 2 slides around. Alrighty. I'm going to write this one on this side of the board. Alrighty, so you've got 4,096 is equal to 8 raised to the 2a power. Now, tell me, what's the difference between the original equation we had over there and the equation over here? What's the difference? Well, let me ask you a question. What's A, B, and K? In this particular one, what's A? 1. What's B?
8.
And K? So do you see the difference between the two equations? Over there we had 150 was our A. This one doesn't have an A, and A is always 1 when there's no A value there. So do we have to divide both sides by anything? No. There's no A value, so you don't have to divide anything by both sides. We're going to jump right into doing the circle method. You have no A value, so you go straight into step 2. If there was an A value, you would actually divide both sides by whatever that number is, but since you don't have one, go right to the circle method. Okay, so here, skip step 1 and go to step 2. All righty, step 2 says do the circle method, right? All righty, let's go. So put my dot here under 8. Draw your circle to 4,096, and then your last arrow goes to the 2x. Step 3 wants me to write it in log form. Do I use the circle method to turn it into the log form? Yep, so log box. I need a box here and I need a box here. Alrighty, so what goes in the first box?
8.
Second box.
4,096.
I'll have to make my box bigger to fit that in there. 4,096 in the second box.
2x.
And 2x in the last box. Alrighty? Alright, I'm going to rewrite it now without the boxes. Now, in this one, do you have a base 10? No, what's the base? 8. Now things become interesting because does your calculator have that button? Do you have the button where you can actually change your base? Now, here's what I mean when I say that. Some of you have this button on your calculator, just that. And some of you have this button on your calculator where you can change the base. Do you have that button? It's okay if you don't. I'm going to show you how to do it if you don't have the button. You should be looking at your calculator. You might have an X down below here. You might have a box right here. But does your calculator have this button right here? If it does not, it's okay. We'll show you how to do it if it doesn't. okay? If you have this button, can you just go put all of that in your calculator? Yes. If you have this button that lets you change this number, you type this in just like this with your button. If you don't have the button, here's how you have to type this in your calculator. Log 4096 divided by log 8. That's what's on the next slide. Let me pull it up so you can see it. This is the next slide. It's just showing you that if they give you whatever number goes here, you can rewrite it like that if you don't have the button. Okay? So the number that's hanging down low beside the G should always be on the bottom. You're trying to figure out what always should go on the bottom. The number that hangs down low beside the G should always be on the bottom. So you're going to do log 4096 over log 8 equals 2x. This is if you don't have the button. If you had a button, you could go ahead and give me the answer for that. Alrighty? So, let's go back to the previous slide. Alrighty, back to the previous slide. Next step, what do I need? What do I got to do next? You can give me this answer. Divide by 2. You can give me this answer and then divide it by 2. Or you can put it on in the calculator at one time. So this is a lot if your calculator doesn't have the button to try to put it all in at one time. But you want to hold on to as many decimal places as possible. You don't want to round anything till you get to the very end. So my question is, when you put this in the calculator, what do you get? Either you have the button where you can just put it in at once, or you can go ahead and do it now. What do you get when you put this in the calculator?
4.
Okay, so you get a 4. This should be a 4. 4 is equal to 2x.
I don't need to divide.
And now you just divide both sides by 2. Usually when you do the math here, you may get some decimal number. It might be 4.235789. Just hold on to as many decimal places as you can. So when you get the answer, don't delete it. Whatever this answer is, then just divide it by 2. Okay, we're good? Okay. That's how you solve exponential functions. You have to turn it into a log to solve an exponential function. You have to turn it into a log doing the circle method. Okay? Question about how to change it if your calculator doesn't have the button. You only need this if your calculator does not have a button. You okay? All right, here's another one that you can actually figure out how to solve it graphically. All right, let's look at graphically. How do you do this graphically? This is solving the log equations. And where is my, I feel like I'm missing a slide. I'm going to put the other ones back in that we had and look so you can see them graphically. All right, let me go to Desmos. The one that we did on the board first. This one over here that we did on the board first. I'm going to put it in Desmos. Let me see what happens if I put it in this way. I'm going to try something really quick here. Equals 150 raised 4 10. Okay, it didn't show me what I wanted, so I'm going to do this. I'm going to change that to Y, make this a T. All right, I don't need the, delete that. Alrighty, and so there's my curve, guys. I'm gonna change my graph a little bit so I can see a better curve. I'm gonna actually do here. Let's change this to oh wait, 150 times 52. Okay. You can see what that graph looks like. Now I want to see where it hits 3,000. And I can't see it because what? My graph is not big enough. I need Y to be at least, let's see, 4,000. All right, you guys see it now? I made my y-axis be at least 4,000 so I could see where the, so this is a way to actually solve these using the graphing tool. Let me erase this so you can see what's on the board here. So the original equation was 3,000 equals 150 times 10 to the 4t power. What's on the right side of the equation? Put it up here. What's on the left side of the equation? Put it here. And wherever they cross is the answer. So, did we get the same answer? You can see it's 0.3253. That's what we have there as the answer. So, that's one way to check and see if you got the right answer. Now, of course, test purposes, you're going to need to know how to do it this way. Okay, but you can at least check it in the homework and see if you're close to your answer. So again, same thing with this one, with the next one. We can do the exact same thing. What do we have up there? Alrighty, and delete this. And delete this one. So I've got y equals 4,096. And I've got y is equal to 8 raised to the 2x power. Alrighty, I got both of them on there. I don't see enough of my graph yet, so I'm going to have to change something. So I'm moving up so I can at least see. I'm moving my graph around so I can at least see where my curve is. Now, I'm going to have to change my y-axis because did I meet up to, I didn't get up to 4,000. I only did it up to 3 something. So I'm going to make it 5,000 so I can see. I'm going to change my my x-axis to 10. Actually, make it 5. So now, where these two meet, is that the answer that we got? Yep, look, we said x is equal to 2. So that is the answer that we ended up getting. It's a good way to check it if you're doing it manually and you're not sure that your answer is right. This is a good way to check it. Set the right side of the equation in Desmos equal to y. Set the left side of the equation equal to whatever it's equal to for y, and see where they cross. That will be your solution. Okay? All right, let me go back to the PowerPoint. That was showing you graphically. We did it algebraically. And now I'm going to go to the homework because I want to see what the homework looks like for this. So let's go and see what the homework looks like for this particular section. So this was 5.3, correct? Let's go down to 5.3 and see. All right, you've got 11 questions. Let's see what they ask you to do. All right, you get to solve. You should pull up your number 1 and see if you can solve your number 1. It should look like mine. Let me see what the rest of them look like before we start trying to solve them. We should do number 1 and 2. Okay. Number 6 will be interesting. So there's a couple of things I need to show you based upon just looking at the homework. There's just a couple of things I need to show you. Alrighty, let's go back to number 1 because I want to make sure we covered everything that you'll need to do the homework. So number 1, we know we did something like number 1. So what should I do for number 1? Do I jump right to the circle method, or do I have an A value to divide both sides by? Go jump right to the circle method. You should be able to do yours while I do mine. So mine is 2200 equals 10 to the x power. Circle method says start here, draw your circle from 10 to 2200 to x. So I've got log base 10 of 2200 equals x. When I put this in the calculator, do I need the 10? No, you do not. So I need log of 2200 should be my answer. What's that in your, what is yours? Did you do yours? I need for you to do yours. Your number 1. Your number 1 should look just like this one on the right side of the board that we just worked out all the way to the bottom. Your number 1 should be similar. You just have a different base value. But your number 1 should be similar to either one of the first ones we just did. I want to know if you're able to get through it by yourself. Put that in the calculator. You gotta put it in the calculator. So that's when I didn't finish mine because I gotta put mine in the calculator. So just like, see when we got over here, we had to put this in the calculator to get that number. So you have to put this in the calculator. Well, let me rephrase that. If you can do it in your head, you don't have to put it in your calculator. And I can't do it in my head either. Okay, while you're finishing that one up, because that one is a really easy one to finish, here is number 2. I want to take a look at number 2. Why? Why should we look at number 2? Because we didn't do one with an E in it, but we did talk about what the E represents. What does it represent? When you see it in exponential form, what should I use, LOG or LN? LN. Am I going to follow this same process? Absolutely. So let's not erase that one. Let me leave this one up here. So now I've got e to the t power equals 199. That's what mine says. Yours says something similar. I'm going to draw, am I going to do my circle method? Say yes. Okay. So here it is. I'm going to draw my circle. Where do I start with my circle? Wherever the exponent is. On this side where the e is, draw it to the 199, back to the t. Alrighty, so instead of LOG, we're going to use LN. So I've got LN, have a box here, which you're never going to see. Alrighty, so what do I put here in this box? An E. You're never going to see it on the calculator. You're never going to type it. I'm doing this so you know this is what you have to use LN. So I'm going to rewrite it at the end without the E there. What goes in the second box? Okay, equals? T. All right, so rewriting it, LN 199 equals T. Think of this as like 10. If ever there's an E at the bottom, you're never going to type it in the calculator, ever. Natural log, that's how this is read. The natural log of 199 equals what? What does yours equal in your calculator? You should have a similar problem in your calculator to do. So let me see what mine looks like if I actually go and do mine in my web calculator. So let me minimize that screen and open up the web calc. Okay, so I'm going to put in natural log, and I want to make sure I find mine. Here is mine on the screen. Natural log of 199 equals, that's what my number equals. It says 5.2933. 5.2933 is what mine says. Let me go back to the homework assignment. I said 5.2933. 5.2933. Is that the right answer? Not quite. Why? It said round to 3 decimal places. How many do I have? 4. So what's my final answer? What should my final answer be?
5.293.
5.293. Okay, yours should look similar to mine. So that's how you do the ones with the E in them. Let's look at the next one to see if it looks any different. All right, this one says use the change of base formula. You only have to do this if you don't have a button. If you got the button, you can just tell me what the answer is. Put in your calculator, tell me what the answer is. If you don't have the button, how should you type it in your calculator? Log 11 divided by log 4. If you don't have the button, you got to type this in your calculator. And then tell me what the answer is. That's called the change of base formula if you don't have the button. The next one, I just want to make sure you're comfortable with understanding. We're still going to use the processes that you see on the right and left side of this board. We're still going to use the same processes. Yours should be similar to mine. This is 4 raised to the negative x plus 9 equals, mine says 49. Am I going to jump right into the circle method? Yes, I am. Do I have an A? No. So I'm going to jump right into the circle method. So here is my circle here, to here.
Is your 9 supposed to be a 4?
Yes, yes it is. Yes, it is supposed to be a 4. Thank you. This should say 4 raised to the negative x plus 4 power equals 49. So I'm doing the circle again. Draw your, start at the 4. Where the exponent is, start at the 4, the base 4. Draw your arrow to the 49 to here. Now, when I drew my last arrow, what is it pointing to? Negative x plus 4. You're pointing to this whole thing, not just to that 4. You're pointing to all of what the exponent is, the entire exponent. Even if it has variables and pluses and minuses in it, you're still pointing to that. So that's me turning it into the log form using the circle method. Log, put a box here. You need a box here and a box here so you can fill all of these boxes in. What goes in the first box? For mine, it's going to be a 4. What goes in the second box? 49. Last box, negative x plus 4. What's our goal here? What are we trying to get by itself? Yeah. And eventually we end up with the x by itself? Is that what we want?
Yes.
Yes, that's what we want. Alrighty. Alright. Do you need this button for your calculator? You can. If you don't have a button, how you gotta write this if you don't have a button?
Log 49 over log 4.
Okay, so you gotta go do log 49 over log 4 in your calculator and you're gonna get some answer. What you gonna do with that answer once you get it? I got some work to do over here once I get that answer. So if I go back to my web calc again, where is it? All right, so log 49 divided by, oops, log 4. All righty, I typed mine up there. Just trying to make the screen bigger so you can see it. I put in log 49 divided by log 4. Let me hit my equal sign so I'll see what that equals. Alrighty. Where's my answer? Oh, it rewrote it. Alrighty, there we go. So my answer here is 2.8073. I will try to keep as many decimal places as I can if you're trying to hold on to it. Equals negative x plus 4. Let me move the calculator out of the way so you can see. Here, go back to the assignment. Alrighty, so when I put mine in the calculator, this is what I got. What should I do to both sides now?
Subtract 4.
Subtract 4 from both sides. Put it in your calculator. Just do it in your calculator. Negative x is equal to, what is that going to be? If I subtract 4 from this, what do I end up getting? Calculator, somebody. That's 2.80735 minus 4. What should I get? 1 point what? Negative
1.19265.
1.192. 1.192?
Yes, ma'am. Let me read this.
651. And that's a negative 1.19265 is equal to negative x. Divide both sides by negative 1. So x is equal to, how many decimal places does it want? 4. So here I've got a positive now, 1.1927. So all you just figured out is if I plug in 1.1927 in this place, this x up here, and raise it to the 4th power is equal to 49. That's what that says. You should be able to do something similar. All right, let me see what my next one looks like. I'm just looking at the ones that I think are difficult for you to do. All righty, how do you do a log equation and it wants to know what the x is? We didn't do that, so I want to make sure I do. Now you got to turn it back into an exponent. Doing what method? The circle method. So here, let's erase this one and put that one up on the board. So I've got log base 3 of x equals 4. Circle always starts right here with the number that's hanging low by the G to this one to that. All right, so now exponent form. All right, so 3 to the 4th power equals, now just put this in your calculator. What's 3 to the 4th power? Somebody check my math. Is it 81?
Yes.
Done. That's how you should be doing yours. Circle method, same thing. So instead of writing log with the boxes, you write your exponent form of the boxes.
So on the next one, are you gonna set each side of the equation to
Yeah.
0?
That's the one that you want to have some fun with that one. You're like, this is not fun. We don't want to do no fun. Okay.
Like, are you gonna do the circle method with?
No, we're gonna go to the properties that you learned. Remember that long list of properties that you learned? When I said multiplication turns to addition,
Yeah.
division turns to subtraction. We get to use those on this one. So let's erase over here because I want to be able to write that one out so you can see it. Alrighty, so you've got 7 plus natural log of 8x. So when you see this natural log of 8x, this is not ln times 8x. It's natural log of 8x is what they're saying. This is 25 minus 2 times natural log of x. Alrighty, so based upon some properties that we learned, let's see if I can figure some things out here. So I'm going to put everything that has an ln on the same side of the equal sign and everything that doesn't have an ln on the other side of the equal sign. So these two are going to be on the same side, and these two I'm going to put on the same side. So I'm going to minus 7 from both sides. I'm going to minus 7 from here. I'm going to minus 7 from here. That gets rid of that 7. So what do I have left over here? natural log of 8x is equal to, what's 25 minus 7? 18 minus 2 ln of x. Okay, alrighty, I need that 2 ln, 2 natural log of x to get to the other side. What should I do with it? Add 2 natural log of x to this side, add 2 natural log of x to this side. These cancel out. So now we have, let's write it below. You have 2 natural log of x plus ln natural log of 8x is equal to 18. All right, now you get to use the properties we learned. If a number got pulled out front, and let me write the properties here so you see it. This says, and this works for LOG or LN. Properties are the same whether it's LOG or LN. If you have 8 times 3, that's the same thing as natural log of 8 plus a natural log of 3. If you have division, where it's 8 divided by 3, it's natural log of 8 minus natural log. I'm just writing the properties that were given to us last Friday. Natural log of that. If you have an exponent, natural log of 8 raised to the 3 power, that 3 comes to the front. These are your properties. So now you can move backwards and forwards. If it's addition, you can turn it back into multiplication. If it's subtraction, you can turn it back into division. If it's a number that got pulled out front, you can put it back as an exponent. So you can go this either way, backwards and forwards. So now, knowing that, can we do anything here?
Yes.
Put the 2 back up here up top, so the 2 comes back up top right there. So now that's going to be natural log of x squared. Okay, plus natural log of 8x equals 18. The plus turns back into
Multiplication.
multiplication. So this plus becomes times. When you turn it back this way, how many times do you write the ln? Once. When it goes from here to here, you're collapsing it. So you only get to write that word natural log one time. When you're expanding it, you're moving to the right. You may have to write that word multiple times to expand it. When you're collapsing it back down, going back to the left, you only go write it one time. So this collapses to natural log of what?
8x to the cube.
Okay, so that's going to be x squared times 8x. You're right, though. You're on the right path. I was just going ahead and adding this step. This is the dot. That's times. I'm adding a step that you don't have to add. Now, can I go ahead and combine this and make this 8x cubed? So now that's 8x cubed equals 18. What is our whole goal here? What are we trying to get by itself?
X.
We're doing all of this just so we can get x by itself. Now, can I use my circle method?
Yes.
Yeah. Once you get it to where it's got LOG or LN of something equals something else, you can now use the circle method. So now, what letter do I put here? There's an E there. Draw your circle. And then okay, so now this is going to be E to the what equals what? Alrighty, so E to the what?
18.
18 power is equal to what?
8x.
Okay. What am I trying to get by itself again?
X.
X. What should I do to both sides? Let me rewrite this real quick. Divide both sides by 8. So now I've got this. And this is equal to that over 8. If you like, you can go ahead and put this in your calculator and figure out what that is. It might be 2.58797. It might be 15.3454, whatever it is. Whatever it is, you got to take the what of it of both sides.
The cube root.
The cube root of both sides. And you can get this on your calculator like this. You can take the cube root. Where's your cube root button? You should have a button that lets you put a little bitty 3 in that little crevice right there. You should have a button that lets you change it. So your button, I know you're used to seeing that button. Where's the button that lets you change it and put a different number right there? That's what you're looking for. And now we can have the answer to that one. That is everything that should be done for that problem. Aren't y'all glad I did that one?
Yes.
So this is all in how you put this in the calculator. I will put some parentheses around this when I put this in my calculator, just so it doesn't take the cube root of just the top and don't take the cube root of the bottom.
When it says an exact answer, it doesn't want a decimal, does it?
When it get correct, when it says exact answer, it wants the answer with the square root in it, with the cube root in it. It doesn't want you to round it, is what it's saying.
Okay.
If it says it wants an exact answer, it does not want you to round it. It wants you to give me the exact answer without rounding. But that means you might have to leave the square root symbol in there. Okay, you can even leave your E in there. That's so easy. It's asking you to even leave your E in there.
So it just wants X.
It'll end up being E to the something if the E can be kept in there. So let me see, the cube root of anything,
So would it be the cube root of what's in division?
Like typing it in the, like for the answer.
So the cube root of E to the 18 is how many times can you pull a 3 out of the 18, which would be 6. So that should end up being E to this is the cube root of this. There's a 3 here. Let me read.
Oh, I see what you're saying.
This is 6 times 3 is 18. And let me rewrite it a different way.
So it literally wants us to do.
It's gonna have you leave the E in it. So here's what it's saying. The cube root, there's a 3 here. How many times can I write E to the something to get 18? So that's gonna be a 6 times E to the 6 times E to the 6. Look at what I just did. How many times do you see E to the 6? 3 times. So the answer for this is E to the 6. That's it. Well, let me give you an easier one. I'm doing square root now. If I say, what's the square root of 4? That's the same thing as saying, what's the square root of 2 times 2? Well, what's the square root of 4? The square root. We're not doing cube root. What's the square root of 4? 2. So whenever you have, and really there's an invisible 2 here. If you're taking the square root of something, you need 2 of each of those things. And whatever one of them is the answer. When it wants the cube root, you need 3 of these same things, and whatever one of them is the answer. If you needed the 4th root, you need 4 of the same things, and whatever one of them is the answer. So this is the answer for this one. Now, here's the question. What's the cube root of 8? Well,
2.
it's 2. Because here's how you write 8. 2 times 2 times 2. Did you know that? 8 is 2 times 2 times 2? Well, how many of those 2's do I need? Just one of them. Whenever you're doing cube root, you need 3 of the same things, and the answer is just one of them. Cube root of 8 is 2. So they're going to want your answer like that, written in that form. So again, we'll pull this up here so you can see this is where we went with this. So let's put in E to the 6 over 2 just to see if it wants my answer exactly like that. All righty, let's put it in.
I don't understand how you got that, honestly.
Okay, with the cube root.
Like, how are you getting the E8 raised to the 18th power divided by 8 all the way to the E to the 6? I just don't see any of that.
So right here to here?
Yeah.
Okay, so anytime you have the cube root of something, you know you can you can separate it. Let's say if I put a 2 here, you can separate it and rewrite it into 2 separate square roots. So first I wrote it into 2 separate square roots, or cube roots in this case. Now I'm gonna rewrite E to the 18th power. So do you agree that A to the 2 times A to the 3 equals A to the 5?
Yes.
that you just add the exponents together. So if I add 6 plus 6 plus 6, is that 18?
Yeah.
That's how you end up with that. So I broke it into 3 easy numbers that I knew would add up to be 18. And they all gotta be the same. But I needed 3 of them that were gonna all be the same. So I knew 3 times 6 was 18. So I used 6 and 6 and 6. The same thing for 8. I knew that it was 2 times 2 times 2, which they're all the same.
Okay.
So now the answer is just one of them. You okay with that? So here again, let me pick another one. What if I ask you for, let me erase this other stuff. I'm just trying to give you what the cube root actually looks like. What if I wanted the cube root of 27? If I said, what's the cube root of 27? Well, what times what is 27? 3 times 3 times 3. So it's 3 times 3 times 3. What's the cube root of 27? 3. You got it? What if I do another one with an e in it? This is e to the 24th power. Let's see if I said, yeah, that's the 24th power. How can I rewrite e to the 24th power? They got to be all the same exponents to add up to be 24. So it's going to be e to the 8 times e to the 8 times e to the 8. Because 8 plus 8 plus 8 is 24. So the cube root of this is just e to the 8. So usually when they ask you for the cube root of these things, it's going to be a number that's divisible by 3.
So is that the way that they're gonna want you to input the answer?
So let's put the answer in and see if we got it right. Hey, the other part is, should you look at the example and see if they did it the same way? Yes, you should, just in case we made a mistake. All right, what did we say our answer was? E to the 6 over 2? All righty. I need a fraction. Let's shrink my screen back down. Come on, screen. Alrighty, shrink my screen back down. E raised to the 6th power over 2. Over 2. Come down. Nope, I didn't mean to put a 2 up there. Backspace that out. Delete. Raised to the 2 power. Nope. Come down here, put a 2. And let's check it. He likes it. Hey, Mikey. Okay, so that's what they want you, how they want you to write your answer. E to the 6th power over 2. And notice it does say it wants it exactly using an E. So they want you to use E as part of the answer. If it is said round to the nearest 3 places, then you would have went ahead and just put all of that in the calculator, and whatever e to the 6 divided by 2 would have been, that would have been your answer.
Okay. And that's what we have to put in if it doesn't say it wants this with the e value.
Correct. It'll say round to such and such a power, or such and such a number.
Does it show that in the example too? Does it show that you have to do that in the example too?
Let's look at it and just make sure it should. It should.
All the way down like that. Sometimes some of the
Well, no, it won't break it down as simple as I did. Like it's not gonna show you how to break this up into these pieces. It's not gonna show you that at all. It's gonna assume that we already know how to do that.
Ms. Harris, you said you recorded this one, right?
I did record this one. Yes, I did. Okay. Okay, let's see what this, I'm just looking to see if the example does what I did. Okay, it did what I did with that part. Continue. Okay, it gives you a little help on the properties. Okay, so it did it a lot like what I did.
okay.
It's similar. So walk through the example for sure. And I will definitely upload this one as soon as I get back to my, it takes about an hour to process it, and then I have to load it. So y'all knew it's funeasymath.com, right? Is where you'll find it.
So
Okay.
Ms. Harris, you know how you said that you drop a test grade?
Yes.
Do you do anything for the quizzes?
Yeah, homework, 2 quizzes and 2 homeworks get dropped
As well as the 2 test grades?
as 1 test grade.
I mean, 1 test grade?
Yes.
Okay. Now, if I got all good test grades and I don't need to drop any, like if I drop one, would it lower my overall?
No, so for example, let's say if you have a 99, a 99, and a 98, and a 90.
Right.
If you drop the 90, it's gonna make that 98 and 99 higher.
Okay.
So dropping a hot is still gonna make the 99 a higher 99.
Okay, all right.
So yeah,
So I can-
it doesn't negatively impact you at
All right.
all.
Thank
Not at
you.
all. Okay.
And you said for your uploaded videos, where do we go to get them?
Funeasymath.com.
Funeasymath.com.
And look for because I date it by the name of the class, so it'll say Monday, Wednesday, or it'll say Wednesday or Monday at 10 o'clock on this day.
Okay.
It'll show that particular time slot. So let me go ahead and stop it.
Okay. And what do